Hi everyone, my name is Mete Sertkan. I'm a PhD student from TU in Vienna, Austria. My colleagues are Neidhardt and Werthner. Together, we developed the concept of implicit preference elicitation from travelers by utilizing pictures. And we deployed this concept as an online user study to evaluate our claims. Thus, the title of this talk is Eliciting Touristic Profiles, a user study on picture collections. The structure of this presentation is pretty straightforward. First, we will give you a brief introduction, including background, related work, and of course, the aim of this work. Then we will introduce our approach to reach those stated aims. Then we will present and discuss our results. And finally, we will conclude our work and give some future outline. Tourism products are rather complex. They usually combine many other items such as transportation, accommodation, attractions, and many more. They are related to emotional experiences, they are mostly intangible, and they have high consumption costs. So decisions like where to go and what to do are not easy to take, and people often have difficulties in expressing their preferences and needs explicitly, especially in the early phase of travel decision-making. Recommender systems are facilitating this decision process. They employ implicit preference elicitation methods and techniques to counter those difficulties. Previous research has shown that it is reasonable to utilize pictures in order to elicit people's preferences and needs implicitly. Neidhardt et al. Introduced a 7-factor model which captures preferences and personality of travelers, and a picture-based method to map people onto those 7 factors. Werthner et al. Use visual and content features which they gained with Google Vision API of Instagram pictures to predict personality traits. Werthner et al. Use pictures out of people's social media streams to classify tourists and make point of interest recommendations. However, all of them are focusing on modeling the user. But in an ideal case, picture-based approaches should be applicable on both the tourist as well as the tourism item in a similar way so that they are easy to compare with. Furthermore, all of them are limiting the user in the choice of the pictures, either by providing a static fixed set of pictures to choose from or by using people's social media streams. Addressing these limitations, our overall aim is a more generic method, where we map any input collection of pictures to an easy-to-understand touristic vector representation. So depending on the source of the pictures, the output of the method is either the vector representation or, in other words, the touristic profile of a user or an item. More details on that will follow in the upcoming slides. In this work in particular, we conducted a user study to evaluate the user profile generation of such a generic approach. Opposed to previous research, we gave participants the chance to use any picture of their choice. Furthermore, we gave participants the opportunity to adjust the resulting profile in order to analyze the difference between perceived and predicted touristic profile. Finally, we are also interested into whether or not the order of the pictures as an additional input can improve the performance of such an approach. In the core of our user study lies the generic profiler, which we conceptually introduced in previous work. In essence, its task is to determine an easy-to-understand vector representation for any given picture collection. We use the 7-factor model of travel behavioral patterns as the underlying vector space model. In other words, the generic profiler determines the touristic profile of users or items, depending on the picture source, by mapping them onto the 7-factor model. We will discuss the 7-factor model in the next slide in more detail. The generic profiler consists of 2 major components, namely the classifier and the aggregator. The job of the classifier is to determine a 7-factor representation for every picture in the input collection. Herefore, we adapted pre-trained RAS nets. The task of the aggregator is then to combine those individual 7-factor representations into one representation, which is in the end the touristic profile of the given input collection. In previous work, we only used the simple average aggregation strategy. In this work, we introduced a weighted average aggregation strategy and compared it with our previous approach. Here, the weights depend on the position of a picture in the given collection. As already mentioned, the underlying vector space model we use is the 7-factor model. It captures the personality and the touristic characteristics of travelers. The 7-factor model and its dimensions are easy to understand and to explain, which is crucial for our user study. They can briefly be summarized as following: sun and chill out, knowledge and travel, independent history, culture and indulgence, social and sports, action and fun, and nature and recreation. Users and items are depicted as a mixture of the 7 factors and not classified to one. For example, the red polygon in this figure is the representation of a tourist, and one can see that he or she is more into culture and indulgence than into nature and recreation. The value of the 7-factor scores lie between 0 and 1. Our user study is designed pretty straightforward. First, we give participants a brief introduction about our topic. We make clear that we follow strict privacy principles and do not save any uploaded pictures at any time. In the next step, we ask participants to imagine their next hypothetical vacation and then to select 3 to 7 pictures from their device, which describes this vacation well. And finally, we ask them to rank the pictures based on relevance. Based on the user's picture selection, we determine a touristic profile. We present the touristic profile to the user as a radar chart, as well as a list of scores, including explanations. The presented profile is with equal chance either based on the average aggregation strategy or on the rank-weighted average aggregation strategy. This allows us to compare both strategies. In the final step, we ask participants to fill out our questionnaire. First, we ask them questions about the picture selection process, where we are interested into the difficulty in finding appropriate pictures and into the source of the pictures, if they use private pictures or downloaded from the internet. Then we ask them questions about the presented touristic profile, whether or not they understood the factors of their profile, how good it matched their preferences and needs, and which factor did not match actually. We also ask the participants to adjust the presented profile in order to obtain the user's self-perception. And finally, we ask some demographic questions in order to get more insights about the underlying sample. Now we will present and discuss our outcomes. The participants were recruited in January 2020. We distributed our user study at the Enter 2020 eTourism conference and through international mailing lists of tourism experts and over social media. In total, 81 participants finished the user study. The majority of participants are between 25 and 44 years old, male, and hold at least a bachelor's degree. And they travel 1 or 3 times a year for pleasure or tourism. We also tracked the timing. We also tracked how much time participants spent on our study. Half of the participants were finished within 2.7 minutes. On average, it took them 4.2 minutes. We asked the participants to select 3 to 7 pictures with their next hypothetical trip in their mind. We also gave them the opportunity to re-rank the provided pictures. The majority of participants selected 3 pictures. Only 21% of the participants reconsidered their initial ranking of the pictures they provided. And those who did reconsider changed the initial ranking between 1 and 4 times. However, 71% reported that it was easy to find some pictures. And pictures from the internet and private pictures were used at equal level. The automatically determined touristic profile is presented to the user as a radar chart, and in addition, as a list of scores with explanations. We presented the user randomly and with equal chance either the resulting profile of the average aggregation strategy or the profile based on the rank-weighted aggregation strategy. If we have a look on the level of agreement with the statement, the resulting profile matches my preferences, overall, 67% of the participants agreed or strongly agreed with it, and only 18% disagreed or strongly disagreed. Similar observations were made if only subsamples based on aggregation strategy are considered. Furthermore, we couldn't observe any significant differences with respect to both aggregation strategies. If we look at the results with respect to the question, which factor of their touristic profile did not match well, where participants had the option to select more than one factor, overall, and also if broken down by strategy, we observed that most people disagreed with the factor sun and chill out, and the least with the factor nature and recreation. Also here we couldn't observe any significant differences between the results of the both aggregation strategies. We gave the participants the opportunity to adjust the presented profile, and 90% of the participants did so, and they adjusted one or more factor of their profile. We consider the adjusted profile as the user's self-perception. The automatically determined touristic profile and the perceived touristic profile seem to be similarly distributed. Significant differences between predicted and perceived touristic profile are highlighted here. For example, considering the whole sample, we observed significant differences in 4 factors. However, if we look closer to the differences, in particular to the mean absolute error between perceived and predicted touristic profile, one can see that in all 3 options, the mean absolute error is relatively small and ranges between 0.07 and 0.16. The biggest mean absolute error is observed in factor sun and chill out, which is in line with the most disagreed factor presented previously. Overall, our approach tends to underrate the factors. Participants were usually adjusting the factors of the presented profile upwards. In this work, we addressed the difficulty of travelers in explicitly expressing their preferences and needs. We conducted a user study to evaluate our picture-based approach. The majority of users were overall satisfied and only few disagreed. Participants disagreed the most with the factor sun and chill out. Presented touristic profile is close to the perceived touristic profile, with a mean absolute error between 0.09 and 0.16, depending on the factor. No significant differences regarding aggregation strategy could be observed. Our approach shows promising results in the user profile generation, but there is still room to improve. Currently, we're experimenting with sequence models to consider the order of the pictures and with attention mechanisms to figure out which of the provided pictures are more decisive. Some participants reported in the comment section that the total freedom in picture choice could be overwhelming. So in future work, we are planning to use hybrid solutions, where we provide participants with dynamic inspirational pictures as a starter. The majority of participants were male between 25 and 44 years old and hold at least a bachelor's degree. Thus, generalizing our outcomes and implications might be limited. In future work, we aim for a bigger sample and for more distribution channels in order to reach a better diversification. We asked people to provide 3 to 7 pictures. The vast majority of participants provided only 3, and only few reconsidered the initial order of the pictures. This might be a sign of lack of involvement. So in future work, we plan to address this issue by using some incentives. Currently, we are evaluating the product profile generation of our approach. Ultimately, we have to bring everything together and conduct a pre- and post-trip analysis. We hope that you have enjoyed our talk. More details you can find in our paper. We are looking forward to the Q&A session. You can try out our approach under the displayed URL or using the QR code. If you're interested in more insights or want to discuss further details, you can reach us per mail. Thank you.